Alright, so what we're looking at here is a time-lapse that I took using OctoPrint and my one-how duplicated i3 version 2 3D printer. But you'll notice that the print bed is not moving between the time-lapse frames, and obviously the print head is quite out of the way from the print itself. That's because I made a post-processing plugin for Cura that allows me to make Gcode injections every time OctoPrint would otherwise take a frame for the time-lapse, basically allowing us to move the print head out of the way and move the print bed to a preset position, giving us this much nicer, more smooth time-lapse. So I'm making this video to show how the plugin works and also to show you how to use it correctly and hopefully avoid doing any lasting damage to your printer. This is a work in progress, so a huge disclaimer here: you're using this plugin at your own risk, and hopefully you're gonna try and test it out with some smaller prints first before you try larger stuff with larger risk of your print head bumping into your print or going out of bounds or something and messing up your stepper motors on the printer. But yeah, the effect is quite noticeable if we compare it to a time lapse taken without the use of the plugin. You can see right here when I was printing a bit for my Halloween costume, you can see that the print is moving all over the place and the print bed is also moving back and forth, which is not as nice a viewing experience. Basically, this plugin is for anyone who wants to make really nice and satisfying time lapses, really sharing what you're making, and maybe also if you, for example, say you wanted to have a consistent lighting for your print all the time. And also, just in my case, I made this whole thing because if we take a look at my 3D print setup here, you can see that that I have my printer sat in this IKEA cabinet here, with my spool holder on top of the cabinet, LED lights all over the place, and a webcam mounted to the side. That's because alternatively what I would have to do is mount the webcam to the moving bed itself. The problem is that it would either be too close to the printed, which is quite large due to the cooler extensions that's already on it, and also the set braces there would be in the way if I put it out to the side. And also, to get a proper image, I'd have to have quite a long camera distance. You can already see the camera position that I'm using now. It is quite a distance away from the print bed itself. So if I had to mount that on the print bed, I wouldn't be able to close the door on my enclosure. Okay, next is a quick warning regarding using this plugin and your quality and the quality of your print. For example, I tried printing this card deck box here, and you can see out to the side there's quite a bit of stringing. So if you're working with a filament and you have a problem with the oozing or stringing, this filament or this plugin is going to make this quite a bit worse. So try testing a few times and see if you're having these problems. I'll just make sure that you really have control over your filament. So that means retraction settings, setup settings, and printing temperatures. You can see here this wood filament that I'm using. I think it's because it's a cheap one that I have, and it seems like those little hairs, they're actually drawn out, that my retraction and setuping is actually not detaching it properly from the print itself, giving us this little piece of fur out to the side. Alternatively, instead of having the printed home out to the side as I have done, for example, if you have a print that's not supposed to be hollow like this box here, you could also just set it to home to the center of the model, like I've done with this little Cthulhu thing right here. And obviously here we have the problem of the aesthetics, that you are not actually able to see the model because the printer is in the way. This of course can be solved by putting the webcam in a more opportune position than I currently have. Okay, also I do not recommend using this if you set your printer to print several objects but printing them one at a time. Maybe you could, if you have everything set up in a row, then have the homing position be separate from them so that you know that it will always have a clear path to the homing position. Alright, next up I'm going to show you how to set all this up. First off, we're going to start with OctoPrint. There are plenty of guides online on how to set this up using your Raspberry Pi, so I'm not going to be going through those details. If we look at the Timelapse fan right here, so obviously seeing as our problem is that the print bed is moving back and forth as we want to take our time-lapse, setting it to timed mode here is not going to help us out, because we are not going to be able to do a Gcode injection that actually can be synchronized with the same time frames as OctoPrint here. So you're going to set that to do time-lapse on set change. So that's basically whenever your 3D printer wants to start a new layer of printing. And also you're gonna see this when I go through the source code itself, which you can also go in and tinker with to your own amusement. Actually, OctoPrint does not take the frame when you on the set change, but when OctoPrint sends the command to your printer to do the set change. I'm gonna cover that in a little bit. Here you can see just normal configurations. You can set your FPS. I set mine to 30, and the time-lapse post roll rendered in seconds. So that's how many seconds after the print is done is it gonna render just the last frame of your time lapse. Okay, next one. This is a very important setting, and it's gonna be important later as well. This is the retraction set hop in millimeters. Why you have to set this here is because OctoPrint is set to take a time lapse frame on every set change. Problem is that that it sends a command for a set change on both when it has to go and start the next layer, but also to do a set hop. Basically, the set hop is a setting that you can use in your 3D print slicer software that makes it so that that every time your printer will do a retraction because it has to travel, it will also raise your nozzle, your printing nozzle slightly in order to better detach the filament from the print itself, which you could see for my my little wood filament thing failed horribly because of my settings, and also to try and avoid the printhead knocking into the print itself. For example, if you're doing something with very steep overhangs and your filament is starting to curl up a little bit and then starting to harden, then you can't actually catch that using either your print nozzle or your fan shroud. That's happened to me a few times. Okay, so next we're going to be looking into Cura here. I'm using the latest version 3.04, I think. Yeah, 3.04. Okay, so in order to do that, I'm just going to bring back something recent. We're going to do the Cthulhu dagger right here. Alright, so what you'll be doing here is you're setting up your print settings as you normally would for whichever needs you would have. I think my settings are still the ones from, yeah, so I use both a raft and support in order to achieve the print you just saw. So whenever your settings are done, then make sure that you, depending on your Cura version, then you may or may not be able to actually see your set hop retraction settings. So you can see if you don't have it, then you just click the cog here on the travel and you enable setup on retraction and setup height here, so you have those options available to you. So see if I enable setup height, and I can set it to do a setup of 1 millimeter. And you can see it slicing again every time I do that. Alright, so in order to use our plugin, you download the plugin from the link below, and then you put it in this directory. So you can see you have your Cura install directory. Then you go to plugins, PostProcessingPlugin, and scripts. Then you just put it there, and next time you open Cura, you will find it up here. So you go to extensions and post-processing and modify Gcode. Then you choose that here, and here are all the ways that you can configure how the plugin is going to act and how your time-lapse is going to come out. So for the Cthulhu one, I set it to do the time-lapse position in the center of my build plate. So that would be 100 millimeters and 100 millimeters in, because mine is 200 by 200 millimeters. Then you can set the travel speed in millimeters per second for when the print bed is going to the capture position. You can also set it to either do retraction or not do retraction whenever it does that, and as well as the retraction speed. For that, you pretty much can just clone the same settings that you're using in the rest of your print. But here is the other very important part of the configurations. It is that you, as well as in OctoPrint, here you also have to set the setup height on retraction. Basically the same way that OctoPrint is going to ignore set changes of this particular distance, so is my plugin, basically meaning that it doesn't have to home back to your time-lapse frame position every time it does a setup. It would not do anything in particular because there wouldn't be a frame taken at that particular time, but it would simply be a waste of time, and we're already adding time for doing all this stuff. And you can also set it so that my plugin will have it do a setup every time it homes to the time-lapse position. And also the last one I didn't mention is how long of a pause from arriving at the position and for it to do the set change. That's simply for it to, if you have a particularly rattly setup, then maybe you want to stay there for a little bit and ensure that the whole thing has stopped shaking. OctoPrint takes frames for the time-lapse on 4 types of occasions. The first one is when you start the print job itself. The second one is whenever the print itself starts proper. That means after your 3D printer's start code has been run through. And if you don't know the start code, you can find that in your printer settings in Cura. Just say manage printers, machine settings, and here you can see these are the things that just came with my one-how printer. So OctoPrint is going to take a frame when you initiate the job and when it's done with the start Gcode. And then the third occasion, that would be the set change that we already talked about. It also takes a final frame when the whole print has ended. My plugin takes care of all of that except for the startup position. So you want to have the printhead be in the same position when you initiate the job as it has when the start code has ended and the print is going to start. The way you can do that is simply write your own little piece of Gcode here. I have one here called Timelapse Start.gcode. And a very nice little plugin here is the GcodeEditor. It was just released the other day, and I can highly recommend it, especially for this task, because then that means that we can go in and edit this little piece of Gcode without having to re-upload it every time. We can do it right in our browser. So the only thing that this code does is that it makes the printhead home to the origin point of your printers, and after that it will move them to our desired starting position. So in this case, I wanted to take our frame at 100 by 100 millimeters in. So my particular starting Gcode leaves my printhead at a height of 15 millimeters, which is why it's set to that setting right here. So basically, we're just gonna start this as a print job, and also you can see we did a set change here. So OctoPrint is gonna make it's gonna do us a time lapse for this. It's gonna be quite uneventful, but whatever. And this is gonna take a little while, so you'll probably want to start this, and then you can, while it's doing that, you can go in and you can set your temperatures. No, you wanted to do that before you started this, because now it's gonna wait to do that until it's done homing in. Right, so this should cover how you install and use the plugin for yourself. Next up, I'm gonna go through the source code itself. By the way, this is only tested on my one-how printer, which uses a RepRap flavor Gcode. So it's all gonna be fitting around that particular setup. But I do still recommend that you try a very small and simple print for your first time. Something that takes like 5 minutes, and you can keep an eye on it and make sure that everything is set up correctly. First, we have the little configuration screen that we saw before. If you want to change your default settings so that you only have to go in and enable this every time you print, and you don't have to change all the values, then you just go in here, you and then you change the values here, and you save, and then it'll look like that the next time you fire up Cura. The older version of Cura, you didn't even have to re-enable plugins because they would stay there persistently between opening the program. But I prefer using the new Cura because it has OctoPrint support built in. In short, what does this whole script do? First off, it takes all the layers in the data being our sliced Gcode. It takes the layers, split them up into lines, and then basically we do a for loop so that we can run through each and every line in each of every layer to look out for important Gcode commands that we have to take into consideration when we do our Gcode injections. Okay, so now comes the actual important parts of Gcode injection, is that we set it to move to the frame position that you set in the plugin in Cura, and it will travel to frame X and frame Y at the travel speed that you set in the plugin. Next up, what we're gonna do is we're gonna set it that we're gonna insert 10 lines of Gcode here. The first one is basically just the pause time that you set in the plugin configurations. But the remaining 9 here, those are here because OctoPrint does not take a timelapse frame when the printer does a set change. It takes a frame whenever it sends the command to your printer to do a set change. So that means that we have to insert this delay right here to ensure that your printer is actually out at the frame position before the set change command is sent out. Otherwise, OctoPrint is going to be ahead of the printer, and this whole thing is not going to do anything. Okay, next up we're going to be setting the new set position. We're actually going to be doing the set change, which is what triggers the OctoPrint Timelapse, and that also takes into account the current set hop distance. Alright, and next we're going to be moving the printhead back to the initial position from which we moved it. Alright, and next we're going to be rewriting the Gcode that we've been interrupting. Alright, so that's basically how the plugin works. But yeah, just make sure, have a close look at your Gcode before and after you try and implement this plugin, and do some simple small models first before you try a 10-hour print with this plugin. Okay, so thanks a lot for watching. I hope you find the plugin useful, and yeah, have a very nice day and happy printing.